Ready? Hi, good evening. Can you hear me? All right, so thank you very much for coming and staying with us for the last session of today. My name is Lior Lukov. Together with me, we have on stage Tom Moser. Hi. We are both members of the Azure Information Protection product management team. And the purpose of today's session is basically to walk you through the MIP SDK. Last month at RSA, we announced that Microsoft Information Protection SDK is available as public preview. Today, I would like to walk with you through the motivation behind the MIP SDK, the vision. We'll have 5 presenters getting on stage and showing you how the MIP SDK basically empowers their own products. And finally, we'll have Tom that walk you through the MIP SDK architecture and show you some codes and explain to you how you can basically empower the MIP SDK within your own products. Before we begin, let me ask you, how many of you are familiar with Azure Information Protection in general? Please raise your hand. Very nice, almost everyone. So for those of you who are less familiar with Azure Information Protection, the main purpose of Azure Information Protection is to make sure that your most sensitive data within the organization is always kept safe and that you have full control on the sensitive data within your organization. Sensitive data can be created in various ways. It can be created locally on your endpoint. It can be consumed for cloud service. You might receive an email which contains sensitive information. You might share it with a colleague. And basically, there are different forms that sensitive data can be created. In order to make sure that sensitive data is always kept and you always have full control into the sensitive data, first of all, you need to detect it. Then you need to be able to classify it and label it as being sensitive data. And finally, you might wish to apply protection and to have like a sort of a fingerprint, making sure that your more sensitive data within the organization is always kept safe. So that means that you have full control, you can track it, you can revoke it, you can apply governance policies. And basically, as the data travels within and outside the boundaries of the organization, you always have control and persistent protection on that data. If you look at the solution, the information protection solutions that Microsoft offered until today, you might find out that there are different solutions out there, either within O365, on endpoint devices, on Azure, etc. But they're all slightly different. They all give you slightly different experience. They do not speak exactly the same language. So one of the main goals of the Microsoft Information Protection SDK is to come up with a single framework that all the products within Microsoft would speak the same language, would use the same label taxonomy that the organization defines. That means that all of them should be fully aware of what is a label, what is confidential data, what is highly confidential data. How can they basically take the notion of a label and apply some additional logic behind that? So we came up with this, so we created an SDK that makes sure that all these different products are fully aware of how they can use these labels. I'd like to show you a quick example. So let me switch here. Those of you who are familiar, this is the Azure Information Protection portal. So if you click on Azure Information Protection, basically, this is the screen where you define the labels within the organization. This is where you start with defining the label taxonomy within the organization, and you basically cite the different types of labels. So for instance, in this example, we have a label of general, public, non-business, confidential, highly confidential. You can see that the last 2 labels here actually apply protection as well. So what we've done here, this is like, that's already exists since 2016. So we basically took the same story and made sure that other solutions, other products within Microsoft can use the same label taxonomy. So if you go to O365, for example, and you click on Security and Compliance Center, let me open it here. So you'll see that there is now a new section within O365. If you click here on classification, you'll find out that there is a dashboard and there are labels and label policies and sensitive information type. The labels here would basically bring you the same list of labels that we have seen in Azure Information Protection. So they're basically rendered from the same location within the portal. So that means that whenever you define a set of rules or DLP rule, which is based on O365, your Auth365 environment is going to be fully aware of the label taxonomy that you defined within the portal. So if you set a label, whether it's been set on an endpoint device or whether it's been set within Azure Portal or Auth365 or even within your Microsoft CASB solution, all of them are going to be fully aware of the notion of the label, and they'll be able to apply protection, and they'll have a persistence way to classify, to label, and to protect documents. Let me switch back. But the Microsoft, the MIP vision doesn't stop there. Let's have a look at the typical enterprise environment, how it looks like. So in reality, our customers are invested in software solutions from different vendors. Not all of them are Microsoft, as we like them to be. So you'll find a solution to some enterprise customers that have next generation firewall by one provider, a DLP solution by another provider, business applications by many other vendors. And all of them, and our customers basically would be interested to have Microsoft to drive a single persistent and consistent experience, information protection experience across all these different products. So for instance, if I create a file from a business application and that file contains sensitive data, I would expect or I would want my full environment to be fully aware that that file contains sensitive data. So for instance, if I created a file in Salesforce or within my Power BI, and I exported that file, and I flagged it, and I set a label on that file that it contains sensitive data, I would like that information being used by my next generation firewall, for instance, or by the DLP, regardless if it's been a Microsoft solution or if it's been a third-party solution. And this is where we bring the Microsoft Information Protection SDK in place. So in fact, all the different solutions which are using this SDK can basically read, consume labels, tag their own files. They can protect, they can apply protection on their different files. And they're also going to speak the same language, the language that your customer basically defined when they created their label taxonomy within the organization. So this is a very powerful capability thanks to using this SDK. If we look at the main goals of the SDK, so first of all, we're looking at driving a consistent experience across various information protection products, not only Microsoft, but also and especially third-party products. We're looking at having a simplified integration model. In the past, those of you who have been using RMS 4.2, so you probably know that there is one library for RMS for Windows and another RMS library for mobile devices. And the experience is a bit difficult. You need to work a bit hard in order to be able to protect data. So what we basically done here is we simplified this solution and we streamlined the process when you basically create labels. All what you have to be aware of is that you now have a new SDK that you can basically set a label, read a policy, set a label, and this is it. If that file requires actually a protection, the protection is going to be applied automatically. You do not have to do anything but simply by setting a label using the SDK. One of the other concepts that we decided to take is to define this SDK or this API as a single contract, regardless if you're a Microsoft product or if you're a third-party product. All the different products are going to use exactly the same SDK. And we started building an ecosystem with top vendors within DLP domain, within e-discovery, within enterprise file sync and share, business applications, and so on. So they're all been using the same SDK, and they can all empower their own products with more use cases by understanding the notion of label classification. And finally, after speaking both to our customers and to our ISVs, we understand that we need to give you a broad support on multiple platforms, not only Windows. So we started with supporting Mac OS. We have 2 flavors within Linux. We have Ubuntu and we have Debian. And very soon we'll have also Red Hat support. Windows, of course, and very soon we'll also have iOS and Android support. Looking overall at the architecture, and Tom later on is going to give you a deep dive into how the architecture looks like. But basically, you can see that the API, we offer a suite of APIs under this SDK. So we basically broke it into two main scenarios. So first scenario, we call it an in-application integration. This is an integration with service providers, which basically own the protocol of the files. So for instance, you're looking at Office, you're looking at Outlook, you're looking at PDF or CAD. So they need an intimate way to integrate with those different APIs. On the other hand, we have business applications. We basically do not own the protocol of the file, but they're basically consume the file. So they are more interested in being able to read a policy, set a label, and this is it. And they do not need more than that. So we developed a very simple to use file API, which basically gives you these capabilities. Now, Tom will continue from here. We'll show you basically how it looks like within the SDK environment, and we'll show you some code examples. But before we do that, I'd like to invite a couple of vendors on stage to tell you the story from their point of view and to tell you the MIP SDK, how MIP SDK empowers.
All right, thank you very much, Lior. All right, so how make we use of this? So chances are high that your company runs SAP. Probably you're not aware of it, but SAP is run by most companies in the world. Now, what it contains is some of the most valuable information there is. For example, some finance information. That's within SAP. Now, within the system, you can make this information very secure. So you have some authorization controls, you know who can access the information, you know what the information looks like, and so on. But you can also export this information out of the system. Now, the problem is, all of these controls that you spent within the SAP system, they're gone. It's a flat file, it's just a file somewhere flying around. Whoever has access to it has access to your data. And to make matters worse, you have no clue of who does that, because SAP doesn't provide an audit trail of this, or a very limited one. Now, what we provide with HaloCore is basically we give the ability for a complete audit trail, so you know and understand which information leaves your system. And with this context awareness, we can give you much of the information that you need. Basically, where does the information go to, who did export it, what kind of information it is, and so on. But this is just half the battle. There is not really, I mean, you know what's going on, but you haven't protected your information yet. And then there is the first feature we provide, or the first idea we have is basically some information should stick within the system. There is no point in having it spread out into the world and shared with everybody. But there are very valid business reasons to have information exported out of the system. For example, you want to share some finance information with your superior. Now, we enable this together with the MIP, that this is shared and protected when it leaves the system. So basically that the company remains the control over the information they're sharing. So extending basically the security model of SAP when the file travels. Now, how do we do that? It's basically the user there requests a document. Now, instead of just giving the document to the user, we grab the document, collect a lot of information about it, and decide then on our server side what to do with it. In this particular case, we decide we need to classify, label, and protect the document. Now, once that's done, we hand over the document to the user, so he or she can actually continue to work as if no changes has happened. Now, we have been in the game for a long time already. We started with actually supporting Microsoft RMS. Now, the MIP is something pretty new. So we had to do some changes on our side to make it work like that. Luckily for us, this was relatively easy, because we are basically, our server is based on 2 components, and the thing we had to do is basically enhance the specific component handling the encryption with labeling capabilities by using the SDK Microsoft provided. And then simply we had to make use of this, and voila, we have the labeling and protection capabilities built in. Now, how does this look like from a user perspective? It doesn't. Our idea is that they basically don't see us, but this happens all in background. So the end user can just carry on with its normal work. For example, here, exporting a finance report and want to share it or download it as Excel. In background, HaloCore does all the magic, does monitor this particular thing, does basically label it and encrypt it with MIP, and then the user sees this. Excel opens as if there was no protection applied previously, so his business process does not change at all, but the document is labeled and protected as the system decided. So the person can control, or the person can share the document with his superior, with his boss, with his colleagues, but the company remains in control of the information. So it's not like this information can flow around, but basically they remain in control. And I think that's very nice that we can put this together with HaloCore and MIP.
Thank you very much, Philip. I'd like to invite on stage.
Thank you, Leo. Hi, everybody. My name is Guy. I'm the CEO of ShieldDocs. And let me tell you a little bit about what is ShieldDocs is all about and what integration we did with the MIP team. So before I'm going to dive into the integration itself, I'll tell you what was the purpose of the integration itself. Here at ShieldDocs, we understand that there is a major challenge in the market today where you have your documentation today in different scenarios that need to leave your company, and you need to be shared, because we understand that once you have documents and once you're in the business world, you have to share and collaborate, and you have different collaboration tools and different sharing tools. And the documents or the information needs to be kept in motion. And we also understood that if we stop the motion, we kill the business. So we needed to do something very unique. We needed to allow motion of your information, but making sure that the relevant person is able to have access to the document and know when to block access to a certain documents. So imagine that you're sending an information now to, let's say, a contract to your lawyer, and the lawyer not going to work on the contract, is actually going to give it to his paralegal, and she needs to open the document now. How do you know to let her open the document? And how do you make it frictionless to the end user with no interruption? And this is what ShieldDocs is here to solve. ShieldDocs is information in motion protection. And with the help of our friends in Microsoft, the MIP team, we managed to get the SDK and receiving labels and interpreted those labels and understand by that the motion of the documentation, where it's coming from. And the way we're doing that is basically we're understanding that on different levels and different scenarios. For example, we have different people that want to share information, and the information may reside in Office 365. And now we put different layers, and understanding the layers with advanced machine learning algorithms to understand what the label says. Is it legal? Is it came from the board meetings? It's our HR information. We also understand the relationship between the user and his contacts. We understand the relationship between the users and their position in the company. We also learn about the folders themselves, who were they shared with inside the company, outside of my company. And then out of those results, we starting to learn the behavior of the user. We starting to learn the information movement. So we're tracking the movement of the information itself. And eventually we understand who can and who cannot open the document, who will have the access to the document. And if we recognize something that is abnormal, we will block access to a person like that. And because we understand the motion and we understand the relationship of your folders plus the labels, what we've done is we letting you see that, okay, if I'm looking at my legal label, for example, and I understand every folder that's related to that label, and I also understand that what's going on here inside my company, folders related to that, and folders that they're actually shared outside of my company, and those represent for me exposures that people have access to something that I not necessarily don't want them to have. So by clicking on one of those folders, we actually allowing them to mitigate that risk, and they have the ability to encrypt that on the fly with RMS capabilities. And from here, we're also tracking the document motion. So because we understand the motion, who can and who cannot open it autonomously, basically, we can branch off every time you have a different copy or a copy left the company, went to someplace else. As in you can see on the right hand, you have a full audit trail, especially when it comes to GDPR compliance and other regulation that tells you exactly what happened with this documentation and if it was blocked and what was the reason that it was blocked. And we did it with the integration with MIP, and because of that, for the end user itself, they continue to use Office 365, OneDrive, completely see-through. Everything's happening in the back end. They do not need to install anything on their computers. And basically, this is what ShieldDocs is all about, information protection in motion. Thank you very much.
Thank you very much, Guy. I'd like to invite Bar from Minorai.
Hi everyone, I'm Bar Tsuri from Minorai. I would like to start with a question that many organizations ask us. Where is my sensitive data? This is a complex question because organizations rely on end user classification. But honestly, users usually don't label their data, so you don't really know where sensitive data is. The problem becomes even more complex when there are different repositories involved, like SharePoint, OneDrive, or data centers inside the organization. Minorai leverages the existing label data and uses it as a training set. We extract the DNA from each file and each cluster of files and then project it on the rest of the data and find the matching labels. To give the user a better sense of the data, we then extract topics and leading words from each cluster. So Minorai's solution is unique because it uses the similarity dimension, while traditional solutions use hundreds and thousands of hard-coded rules, like regex, as you can see in this diagram. Our solution is based on byte-level recognition and unsupervised clustering, which is agnostic to file types. If it's a Word file, PDF, PowerPoint, or just a 3D model, we will find it and match it. Our system is proactive and prompts the users with recommendation based on his interests. I would like to go over with you about these use cases. We have the automated data classification. We talked about it before. We saw how with the DNA extraction, we can apply the corresponding labels on the rest of the data. The secure cloud migration, with our ability to extract topics and leading words from each cluster, the user can easily pick up those files that he wants to migrate online. And for data minimization, our ability to extract the DNAs of the files can enable us to get rid of those duplicated files and near duplicated files that resides in different repositories, as well as over hundreds of terabytes. And my giveaway message to you, this slide doesn't exist. My giveaway message to you is to empower Microsoft Information Protection with Minorai AI.
Thank you very much, Bar. I'd like to invite on stage Nimrod from Big ID.
Hi. So my name is Nimrod, not Nadav, from Big ID. And at Big ID, we believe that privacy matters, right? And privacy for a long time has been an afterthought of security and was really reliant on policies and procedures rather than product. And the reason for that is because privacy is hard. It's really hard to handle the privacy requirements that require you to know whose data you're handling, who are the people that need to be protected, and address issues around personal information, not only highly identifiable PII, but actually any information associated with the individual. The transaction the individual provided, the running routes of an individual, maybe even the preferences and so forth. Also, we are dealing with a world with big data. We're dealing with a lot of different types of data, structured and unstructured, cloud and on-prem, business applications, big data. And especially with privacy, we are looking at requirements that require you to understand the business processes, require you to understand why is the data being collected? What is the purpose of processing? Is there consent for the data? All of those are very hard problems to solve with a product. And this is the challenge that we took. And the idea of Big Idea is really innovation around 4 main areas. First of all, we discover data. But we don't just classify the data. We don't involve in classification. We involve in correlation. We correlate the data to the identity. We understand whose data it is that is reflected in the document. Whose social security number is it? Whose address is it? Whose transactions are these? This is important for privacy, and I'll talk about the reason why. The other thing that we do is we don't only discover personally identifiable information, we discover anything correlated with the identity. And that aligns very well with the new requirements and the broadening definition of what personal information is. Because anything associated with the user is personal, and you need to protect it. We handle structured data and unstructured data. We handle data in the cloud and on-prem. We handle data in big data repositories and in business applications like SAP or Salesforce. And we also assess the risk around the data. This risk assessment propagates or aggregates all the risk factors, such as the type of data, where it's stored, but also whose data it is, and helps you analyze this risk to understand and perform data minimization. What is the risk contribution of each attribute I'm collecting about my customer? Where is it stored? Do I have duplicate data? All that is needed in order to minimize your risk from a data perspective. And finally, we take all of these use cases and we build operationalized flows that help you address specific regulatory requirements around privacy protection. So for example, first of all, we build an inventory of all of your data, almost like a directory of your customer data, what data you store about them, and where that data is located. So you can determine the residency of the data. Are you storing data of Russian residents or European residents? Are you storing data of children, customers versus employees? We help you operationalize the right to be forgotten. Someone calls in and asks, what information do you store about me? You have to be able to find that data and erase it or provide a report about it. We provide that flow because we know whose data is found where. And we help you tie this into the business processes. We help you build business flows that describe how personal information is being used and tie those business flows to the actual data that is stored in your file shares, in your databases, in your big data repositories, so that you can report on the purpose of processing. Why are you collecting that information? What is the purpose? What is the business purpose of that? This has typically been a completely manual task done by the Big Four, PwC, Deloitte, Accenture, and these guys. And now we're giving them tools to automate that and make it continuously compliant. So as data changes, the business owners are notified about those changes and can provide the corrected purpose of processing. Why is this important? It's important because there's a new regulation coming from the EU that focuses on privacy protection. It's not only about data protection like PCI or HIPAA or SOX, it's more about privacy protection. It's about accountability towards your customers, towards your employees, towards your partners, and the data that you store about them. And this regulation applies to everyone, not only to citizens in the EU, but also to organizations in the US or in other parts of the world that are processing European resident data. And this regulation defines very clear use cases that need to be applied around privacy, whether it's the right to be forgotten, whether it's data processing or record keeping of processing activities, risk, and so forth. So our integration with Microsoft Information Protection really allows us to extend the Microsoft Information Protection from data protection to privacy protection. We can label files and soon also database tables that store information about European residents and tag them as European resident data or GDPR scope. We can find tables and files that contain children information or customer data versus employee data and label them as such. And that allows the Microsoft Information Protection tools, Microsoft CASB, or other tools that handle the data to then enforce policies that are sensitive to the identity of the data, that can enforce not only data protection policies, but also privacy protection policies. And that's really the value that we bring to Microsoft in this space, and also Microsoft brings to us in that context as well.
Thank you very much, Nimrod. And finally, last but not least, I'd like to invite Guy.
Hi, my name is Guy Leibovitz. I'm the CEO and founder of Cognigo. Cognigo is a company based off New York City and Tel Aviv in Israel. And we are set on a mission to make sure that sensitive data will not fall into the wrong hands. So data is the new currency, but today we see that it really lacks the right protection measures and policies. And we actually, at Cognigo, we identified 3 trends in data protection. So our job actually became more important. The first one is the increase of impact of data breaches. We just saw what happened with the Zuckerberg case. And the OPM, JP Morgan Chase, and others. So there is kind of like new awareness about data security and data privacy. The second thing that we're seeing is digital transformation. Companies are moving their data to the cloud, and what is really creating is isolated data silos. So today there is diversified solution for diversified data silos. And what we're trying to do at Cognigo is to provide a single pane of glass to control all of the data. And the third thing is the GDPR, which presents the most ambitious changes to data security in the recent 20 years or so. And one big misconception about the GDPR, it only applies to Europe. Actually, it applies worldwide. So our way to solve it is something called cognitive computing. Cognitive computing is essentially the ability to train a machine and actually bring human-level intelligence using various AI algorithms. So what we actually do. So first of all, we have entity recognition. So I can understand that Guy Leibovitz is a guy, and is a person, for instance, that Seattle is a location. We can actually understand every part of a sentence using deep attention networks. We can also do supervised learning and clustering based off examples. In that case, AIP is amazing because my background is as a data scientist. I was always looking for data samples and tagged data samples. So AIP and MIP can actually bring this out of the box. Clustering, and another cool thing that we're doing is we can actually correlate between CRM and fuse this data to unstructured data as well in a linear time. So if you have 1 billion customers, we can do it in a linear time, which is really amazing. One thing that I want to talk about is a little bit how we work and how the cognitive computing works. We're using a technique which is called meta-learning. And one of the things that we are doing is when we're examining a document, in this case, it works like the human brain in a way. First of all, we're looking at the structure of the document, and then we look also to the text features, and so we can actually classify and understand that this is a system specs, first of all by the pixels, and then by the textual features. Good, so how does it work? So first of all, we identify the data. We categorize the data using data samples or MIP data samples that we get. And we bring also out of the box AI, which is clustering, topic modeling, and others. And then it's Google-like kind of a search engine that works on structure, unstructured, cloud services, and others. So what kind of questions can you ask? You can actually ask, where is Gal Gadot data? And it will show you across the entire enterprise where a data subject information resides. You can actually ask more security-related question, like, do I have sensitive information in my non-production environments? And you can get it in less than 5 minutes. And again, if we're looking at a GDPR scenario, we can actually mitigate GDPR in the cloud and make sure that all the data subject rights can be exercised. The third thing that we're doing is protection. So we can do human-free labeling. So because we understand the data, like the human brain, we can actually don't need the human being to manually tag the files. So we can do it automatically. And then we can actually use encryption and other sophisticated policies as well. And the third thing that we're doing is related with auditing. So we can actually audit the data using RMS, or we also have a partnership with other vendors. We can actually demonstrate GDPR compliance, and we can receive alerts every time we see a privacy or security violation. So I want to talk about the benefits in combining the two products. So the first one is it's human-free, as I said. There's no need for manual classification. You can just use AI to find a category and the right classification tag. The second is human beings, as human beings, we're prone to error. And it's very manual classification is very subjective. And what we're trying to do is create a single source of truth for every document, a database, column that there is in the organization. Another thing that we're doing is we can actually apply MIP on historic data and dark data, and we can actually monitor the application of or the implementation of MIP in an organization. We actually do it quite successfully. So say that I'm implementing MIP. Do I know if the Azure department are using that? Do I know if the finance department are using that? And the last thing, which is also important, is to actually use our cognitive computing together with MIP security to achieve privacy by design and security by default, which are basically the pillars of GDPR. So I want to talk about case study, which actually we do together with Microsoft in a big international manufacturing company here in the US. So the goals were, first of all, we actually managed to discover, label, and secure sensitive information, which is design documents, which are very not textual, just CAD files, and PII spreadsheets because of GDPR. Then we did something really amazing. Together with Microsoft, we actually created microsegmentation of data. So that's a new kind of theme. We can actually segregate data based on perimeters that are defined in our product, and enforce it, of course, with MIP. And we can also monitor the permission and audit and find audit trail using RMS log access logs. And of course, we helped using a new technique which contains documentation of the GDPR and the ability to exercise data rights within our product. So thank you so much.
All right. Am I good? I'm good. OK. So again, I'm Tom Moser. I'm a senior PM on the Azure Information Protection team, and I'm going to go through some steps here. Well, first, a little bit about the SDK and what we actually delivered in this private preview, where we're going in the future, and then we'll dive into some code, and I'll show you an example of a sample app that I've written. So going back to this slide, which really describes the three components of the SDK, which I'll get into here in the next few slides. But you can see that really we've intentionally segregated these two sides of this slide. On this side, we're really looking at the things that are going to use the services and applications that we use our policy API to really just display what's available to a user and the actions that a certain label should take. And then on the other side, we have all of our applications that are quite likely going to use our file APIs or protection APIs. So they're really just working on files as they cross through some service or some, like an application firewall, for example. This describes it, pivoted a little bit more, but you can see that we've really got the policy API and the protection API are down low. And then above that, we have the file API, which is really an abstraction of the two lower APIs, and kind of brings functionality from those two things together to be able to apply labels to any document, apply protection to any document, and then all the other actions that would go along with that file format, and I'll dive more into those in a minute. You'll notice on the left that there's this MIPC, which is our classification API. We're still working on that. We'll ship that post-GA, so hopefully later this year sometime. Kartik's not around to yell at me for saying that. All right, so the protection API. This is the first one. Is anybody familiar with RMS or our RMS SDK? We've had for a while, some people, yeah. It's great, not really. So we've taken and we've come up with this protection API, which is bringing things closer to the information protection world. And so rather than relying solely on data protection, we're relying on labeling. That labeling then applies the protection to the documents. The protection API is really intended to protect files or data streams that our file API won't protect. So a good example of this might be if you own you're a developer that writes a CAD/CAM application, and you use a custom file type that writes out your 3D designs out to disk. Our file API will probably not understand your proprietary format, or it could be an open format, and we don't support it yet. You could use our protection API to take a plain text string, or stream rather, pass that stream into our API, and then the output would be the ciphertext or the encrypted content, as well as the publishing license for that information. And if you're more interested in the details on publishing license and how the protection works, come to our session tomorrow morning, which I'll show you at the end, or swing by the booth in the expo, and you can talk to one of us, and we can explain how the actual protection works in depth. So the API is responsible for protecting the content. Give me some encrypted or unencrypted content. Give me some plain text. I'll give you back some ciphertext. It's responsible for decrypting protected content. So give me ciphertext with a publishing license, and I will give you back the plain text with some list of rights. And the most important point here is that the rights management, or the rights enforcement rather, is up to the developer. And so if you've used any of the Azure Information Protection functionality in Office, you'll notice that it can do some things like block copy, block save, restrict the ability to print. That's because the Office team has done the work to implement that. So they look at the file when it's been opened. They say, OK, Lior has rights to print this and doesn't have rights to save it. Well, when he tries to go to save it, that'll be grayed out, but he'll be able to print the document. You, as an application developer, would have to enforce that in your application. So when you decrypt the document, you would look at that license and say, OK, Lior has the right to print this design, but not to save it to disk. And your app would have to then implement that. So it's really up to you to enforce that. So there's no magic in the SDK that says, you can't do that just because you've decrypted it. You have to make sure that happens on your own. Next up is the policy API. And so the policy API will primarily be used by applications like Office, like a PDF authoring application. The CAD/CAM example that I used might use the policy API. And really what it's going to do is show you the policies that are available for a user. So when I'm a user who launches my CAD/CAM application, I'm just going to keep going back to that, I'll see my policies. So in Office, I would see my classification interface. That would be specific to my user account. Now, the next thing that I can do with the policy API is when I actually click that label, my application will return some label ID to the API. The API is going to return back a list of actions. And those are the actions that my application should take on my file. So the example would be I click confidential as a user on my CAD drawing. We call the API with that GUID. It returns these list of actions. And those actions might be add a watermark, add a header, add a footer, apply protection, and then the list of metadata that I should apply. And then it's up to you as the software developer to then implement that in your application. So we won't do any of the work for you there. We're being lazy. No. You'll have to do that in your own application. So you can think of like an Office doc. The Office team would have to write the code that once I've clicked that button, do the rest of the work. But we'll tell you. And there's a bunch of unique things that we can do. So you could say, if this document's not labeled at all, what should I do? Or if this document already has a label and the user tries to apply a new label, the SDK will compute that action and say, OK, remove all this information and add this information. And when I get to the demo section, the first thing I'll show you is actually our sample application giving you the compute actions. And we can take a look at that because we'll have a little more time than I expected. So really, again, the policy API exists to expose the labels available to a user and then really to compute the actions for each label. And finally is our file API. This is the one that we think most of our ISV partners are going to leverage heavily. We think that most of our customers will leverage heavily. If any of you write line of business applications within your own enterprise or for your own customers, this is quite likely what you'll use to protect files that are exported. So going back to the HaloCore example, that's a great one of somebody exports a file from a line of business application. We know that this is some sort of sensitive information. Let's apply protection to that file at export, and then we know that that file is not going to float away. So really what the File API provides is an abstraction of the Policy and Protection API. But what we've done is implemented a bunch of common file types, Word, PDF, certain image types. And for things that we don't support natively, there's a generic P file wrapper. And what we'll do is essentially let you pass in a label ID, pass in a path to that file, and we'll give you back a protected file with all, or maybe not protected, but labeled file with all the appropriate actions having been taken for you. So it's really simple, and that's the demo I'll show you with my sample application. And then tomorrow in our workshop as well, you'll actually get to sit down and get hands-on keyboard to build it yourself. So again, we support the ability here to read labels from supported files. So as files are flowing through my line of business app or flowing through my CASB or whatever I happen to be writing, we can very easily see if that file has a label on it and then take some action. We can apply labels to the supported file types. And then most importantly, the supported file types can be expanded. We're not open source yet. The SDK is not open source yet. It will be, and at that point, it'll be very easy for people to either write their own integration that they can then submit to us, and if it's great, we'll merge it. Or you can come to myself or Kartik or Lior and ask that we implement your specific file format, and we can work with you to get that done. All right. And if there's any questions, feel free to interrupt me. There's some mic right there. And some key concepts. So as I get into the demo here, there's some things that I'll show you in the SDK that are really important to understand from the beginning, so especially with the File API. So we have three important things when I want to work with our File API. The first one is a profile. And a profile is going to be a per application object that we create that really controls information about local state storage, handles my authentication delegate, handles my observer for asynchronously creating that object. And it's really the root of everything. All of my applications will have just one profile created. If I'm working with like an Office application or a desktop type application, I'll have one profile, and then to that profile, I'll probably just add a single engine. If I'm working with a line of business app that's maybe a service-based application, I could have an engine for every user that authenticates to that application. So I could have hundreds of engines, and I'll add all of those to the profile. The engine is actually responsible for, in the File API, all of our file operations, or in the Policy API for any of the policy operations that we perform. And then finally, once we want to actually work on the files, we'll add a file handler. The file handler takes in some parameters, typically a label ID in a file, and we can either set, remove, delete, update, whatever we want to do with all the labels. And so now I will jump over to the demo if my machine turns back on. Sorry. All right, so first question. How many of you live in C++? Who does C++ every day? All right, a couple. OK. Good news is we're working on a .NET SDK for this. Today, the SDK is C++ only. It's cross-platform C++. So as Leroy mentioned, the great thing about it is that it works on Windows. It works on Ubuntu, and I think Debian today. It works on Mac OS, and we're shipping support for Mac or iOS and Android in the near future. And so you'll be able to write this across any of those platforms very soon. So the first thing I'll show you here is the sample application that we package with the SDK. So first, you can go off and you can grab the SDK itself on GitHub. We've released it there for now in the download center. In the releases tab on this project. So the project is just Azure AD MIP SDK binaries, or aka.ms/MIP SDK binaries. You can grab the SDK there. And within the SDK, we've included a bunch of samples. And so what we did. There we go. So there's a samples folder in here. And that sample folder has really three samples in it, one for file, one for RMS, and one for UPE APIs. There's an auth component in here. Today, because we don't have ADAL for C++ publicly available, we use Python to obtain a token and actually authenticate. So you have to have Python installed on whichever machine you run this on. But it is cross-platform. It works pretty well on Ubuntu, macOS, and Windows today. We also include the source code for that. And so the samples, if I dig into this, actually has all the source for those. So you can run the samples and go in and take a look at the source code and start to understand how these applications work. If you do that and have any feedback, please feel free to reach out to myself, Kartik, or Lior, and we're happy to hear any feedback or make any changes that you think might make those samples more effective. So if I jump back here to wherever it went, oh, there it is, in PowerShell. So I mentioned we have the our UPE sample. So I have this sample application, and if I just run this today, there's a whole bunch of different options I can pass in, username, password. I give it a client ID, which is optional. And then you'll see some things in here. Oh, token. We can just mint a token and pass that token directly in as well. And so you'll notice there's some things in here like simulate policy change, list engines, list labels. We won't talk about list engines. But I can run this with some parameters passed to it for my username, password. Oops. And if I just say list labels, this will hopefully authenticate, go out to the service, and download all the labels that are available to me today with all the metadata about those labels. And so right away, the policy API is just easily exposing all that data. I could show you the code for this as well. It's pretty straightforward to implement. And this will, in your own application, allow you to expose either a user or an administrator what labels are available in their tenant. So the first thing I'll do is just copy one of these labels. We'll do this child one here. Actually, we'll just do this. So now I'm going to rerun that same sample, but you'll see that instead of list labels, I say compute actions, and I give it a label ID. And if I run that, it's actually going to take that label ID and compute what I should do as the application developer to that file. So in my own application, my CAD/CAM design app again, the user clicked this label. This label had an ID of this D7 blah, blah, blah GUID. I pass that in and say, hey, API, what should I do? And it returns 4 actions that I should take. The first one is add a content header, add a content footer, protect with the template. So this is where we actually apply the AIP protection based on a template to that document. And then finally, apply some metadata. And this would give me the exact metadata that I would need to apply to that file. I can also take one of the other labels and similarly say, oh, label ID, and copy that in. And I have to provide justification because it's a downgrade. So it tells me there that the action I should take is that I have to justify the downgrade before I can actually apply that label. And for the sake of time, I won't dig through more, but you could dive through this and you could pass in different IDs for different labels, and it would give you an action like remove this, apply this. So the API makes it really simple to take your customer's well-known global data classification taxonomy and to apply it to your own applications or services. So the next demo I have, so this is the C# application, even though I just said it's C++ only, that I'll demo tomorrow. That if you guys come to the workshop, you'll get a chance to get your hands on. Instead of going through the code first, I'll go through the demo, the actual app first, and then we'll work backwards from there. So I mentioned this is C#. We actually used Windows Runtime to build a C# application, and then had to convert everything to Windows Runtime compatible types and to call that from the C# app. So we're actually using a C++ MIP component here. You'll see this over here. That's my C++ application, and then my front end of the app is actually a C# UWP app. And this is super basic. I'm not a developer, and I'm just a PM, and I built this. So you guys will probably build some pretty amazing things. So the first thing I'll do is click login. This should happen seamlessly. I'm using ADOL. I've already cached a token, and so what I should see is once it logs in is that it's populated the labels. If I hadn't logged in, I would get the regular ADOL flow that everybody's familiar with. I would provide some credentials, get a token, pass it to the SDK, and then it would pull down the policy for me. The next thing I can do is actually open the folder. So in this test files directory, I have a bunch of just test Word docs that I've been demoing with. And so I open that. And so what that did is actually read every file in the directory, and then it checked every file using our SDK to see if it has a label applied. And the default set that I'm using here, none of these files have a label. And so now all I have to do to set a label is, as the user, click the document that I want to label, I can select one of my labels from my list and say set label. And immediately the SDK says, or the app comes back and says, hey, we applied this label. When I click OK, it should refresh this view and should refresh this view. Try a different one. Oops. Try that one. There we go. I have no idea why that first one didn't work. So it creates a file called test_modified, and you can see that it actually applied my Contoso FTE's highly confidential label to that document. An important thing to note about the SDK is with File API specifically, we don't overwrite any files that you've created. So nobody can go out to a file share and just overwrite everything that's there. We actually will we require a new file name and then leave it up to you to rename or remove the old one and put the new file in its place, because you're actually generating a new file with that metadata and protection applied to it. So I can click through these and just apply the label to a bunch of items. And you can see that one's labeled general now, and I can make this one public. And then finally, when I'm done applying labels to all this stuff, I can just say save changes and put this into an output folder. And so here in my output folder, if I open up one of the modified files, I seem to be missing one. And view the metadata on that file. We can see that it applied the labels from the SDK. So it actually did label that file for us. You might notice if you're testing this, if you start to actually play with the SDK and as you're going through it, you try to view it in the AIP bar. So this is the AIP bar that we have today. The labeling taxonomies between the two aren't compatible. So this is what you might hear us refer to as AIP v1. Once we ship the SDK and it's generally available, and I think the work's actually happening now, we'll ship a new version of the AIP bar called AIP v2, and that will understand this new labeling taxonomy. So for today, if you're testing this, you either have to use your application that's leveraging the SDK to read the labels, or use our test application that we've packaged with the SDK binaries to read the labels from that file. All right. And this one here, I'll try to open it. It's going to fail because I don't have an identity logged into this machine that can actually open the file. But we'll notice that this one's 62K, which for a file with one line in it is a pretty good indication that it's been RMS protected because we've encrypted it. If I open this up, it's probably going to yell at me that I don't have an account that has rights because I'm not signed in with an account that has rights. But if I wanted to sign in with my test tenant here, I could sign in and it would actually open that file for me. But it's my everyday machine, and I don't want to go messing with my identities. All right, so if we jump back to the code, I'll mostly ignore the C# code only because it's not important for the scope of this discussion. Implementing this was relatively straightforward. So if we look at our authentication here, well, first we have this source file called File API. So everything that I do, I implemented in a class called File API. File API takes in this iToken provider that we're using for auth. If you want to dive into that more, come tomorrow and we can talk about that more in the workshop. Actually, a couple of the software engineers from the team will be here tomorrow to talk more about any in-depth discussion you might have about why we made a certain decision from like a C++ convention standpoint. So the first thing we do is create an auth delegate. Again, that auth delegate is just getting a token from ADOL, passing that into the SDK. The SDK handles the rest. So really to get started with auth in the SDK, we just need a token. So we pass in that token. The next thing I need to do is start to create my profile. So I mentioned that the profile is the base class for all operations in our SDK. So I'll pass in some application settings, and these are mutable. I can make these whatever I want them to be. So in my case, in the lab tomorrow, I just used the GUID generator in Visual Studio, generated a GUID, put it in there. And then I created a friendly name called build ILL tutorial, but you could call this anything you want. So here I've created this MIP application info object and then set a couple properties on that. I create a storage path. So the SDK itself can either run completely in memory, where I go and every time somebody uses it, I fetch a profile from the service and I cache that locally in memory. Or we can store them on disk, which if you're working with hundreds of these things in a cloud or line of business application, it's probably going to be beneficial to put them on disk instead of making a bunch of cloud calls every single time. So I define a storage path here, which is just my temp folder for my UWP app. All of our operations in the SDK are based on Promise Future and C++. I will not get into the details of Promise Future right now. But in order to implement that, we have to actually implement an observer for the callbacks for that asynchronous call. And so we've implemented a file observer, file profile observer, file handler observer, et cetera, as part of the SDK. And then I've created my own custom implementation here to extend that for Promise Future. Hopefully we'll have some better samples of this in the next few weeks out on GitHub for people to consume. And so I'll create that observer, which is just my file profile observer implementation. And then next I take what I've done so far, I create a file profile setting. So this is really saying, hey, everything that you're supposed to do, where you're supposed to store your files, whether to use in memory or not, my auth delegate, my observer, and then the application info that I set above, store that in the settings object. And then we get to the fun part, where I actually then use Promise and Future to asynchronously create that profile. Everything we do is async because we don't want to block the application, given that we're working with files, that we're making calls out to a cloud service, that we're dealing with encryption and decryption. We wanted to make sure that there was nothing blocking as we perform those operations, or that you could write your app in such a way that things wouldn't block. So the next thing I do is create a promise for the file profile, create the future based on that promise. And then finally, I just call MIP file profile load async. I pass in the settings we created above. I pass in the promise that we created above. And then lastly, I have this global private variable declared called mprofile. We just get that future state, so that's actually going to go out, and if the operation's not complete, it'll block, and if it is complete, it just fetches the value and then stores it in profile. So really creating that profile, which is the root of all of our settings, takes about 5, 6, 7, I don't know, 10, 12 lines of code. And so once we've created the profile, now we can add engines, and engines will add per user to start to perform operations against our files. So creating the engine is relatively simple as well, just 5 lines of code. We create a file engine settings object. The engine settings is going to be the engine identifier, so we can create a unique identifier per engine and then store that for the users. And then the second value here is just some telemetry type data. So if I wanted to create a custom string in here to track something in my app or debug, I could put that in. There's a third optional parameter for locale as well. Again, create a promise for now a file engine because we're looking to create an engine, and then the future for that. And then finally, because that profile is the root of all of our operations in the SDK, we add engines to a profile. And so we simply call mprofile add engine async. We pass in those engine settings we created. We pass in the engine promise. And then finally, once we get that value, it'll return that engine. And now we've essentially initialized the application for actions to start to happen on behalf of a user. Now a user, we can begin to add file handlers to read labels, to write labels. But overall, could essentially integrate from a working with file standpoint in about 15, 20 lines of code to get started on this. So next, we'll ignore this here because that's all converting standard C types to Windows runtime. We want to get labels from the service, and that was the next step in my app that you saw when I actually logged in. It populated all the labels. That's pretty simple as well. So I'll create a type here, an object here of vector MIP label. So it's really just a vector of our label format. And I call that labels. And I just call that engine. So I created that engine. It's ready. It's initialized. I say, hey, engine, give me all the labels for this user. And it goes out for that authenticated user, lists all the labels, stores them in that object, and then I can just do whatever I need to do in my application with those labels. In my case here, I had to convert them to a Windows runtime compatible type and then return them back to my C# app. So everything after this, we won't cover much tomorrow in the lab. It was really just a result of how we wrote the demo app. And now next in the app, when I actually opened up my file, it enumerated that directory of files and showed me the labels on each file. And so here we'll talk about how to create a file handler that then can read the files. And again, it's about 5 lines of code. So the first thing we do is create a handler. So this is a MIP file handler object. And because that file engine actually implements all those file actions and operations, we have to create a file handler. And so on mengine, we call create file handler. We give it a path to the object that we're working with, path to the file. And then we, again, give it the observer to call back on for the asynchronous call. So we have this file handler observer implementation. We pass that in. And then we're back to the promise future again. So now I create a promise for type content label because that's what we're going to get back from the file when we read the label. I create the future. And then now I just call handler get label async, and I pass in that promise. And when that's complete, it'll return the value to the future, and I can say get the future value, and now I'll have the label. So in 5 lines of code, I can read the label off of any document that's passing through my line of business apps or my SAS or CASB or wherever I have files flowing. And finally, we'll set a label. And so the last thing I showed you is actually clicking a file and then setting the label in that file. And this is as simple with one catch, and that catch I'll explain here in a second. So again, I create a file handler, exact same syntax. I'm saying auto handler, create file handler from mengine, give it a path, give it the observer. And then I call handler set label, which takes in the label identifier, which I can again get from list labels. And it takes in some labeling options. And so we have various options as far as how the label is assigned, whether it was assigned by a service. We might say it's standard, I think is that one, and then privileged if it was assigned by a user. And then we have this auto thing that's its own entity. And so we can define some labeling options, custom schema, that kind of thing here. But there's one extra step I have to take. So at that point, all I've done is in memory said, hey, on this file handler, do this thing to this file. But we haven't committed anything yet. So the last call that we have to make, and for those of you reading ahead, can see that we create this promise future again for type bool. And then we call handler commit async. And we pass in an output file. So this goes back to what I mentioned a few minutes ago, how we actually have to give it an output file. We'll call commit async, give it an output file, give it the promise that we just created. And it will asynchronously apply the label to the document, that source document, write it to a new file, and then return the future value in this case, which is going to be whether it was successful or not. So we'll get a bool back on whether it successfully wrote that label to the file and then to disk. So the commit is the important part here. I could do a whole bunch of things to the file. I could add labels, set a justification, et cetera, but nothing will happen until I actually run the commit. And so that's it. That's an overview of the application. So tomorrow, if you come to our workshop, you'll have a chance to get your hands on that and actually write it yourself. If you want to add to the application, there should be some time for that as well. All right. Any questions? Anything I can clarify? We'll be here for impudence. We got 7 minutes left, so plenty of time. Yeah.
Can we extract labels of a previously protected file without changing the file?
Can you extract the label? Yeah, so we write OK, so the question was, can we, and correct me if I'm wrong, can we extract the labels from a protected file without changing the file? Yeah.
Can we read the labels of protected file without changing the file?
Yeah. Yeah. So the labeling, the question was, can we read the labels from a file without changing the file? The answer is yes. The metadata is stored in plain text. So the label information is plain text in the file. So any system can read that. The contents will be protected. And even if you couldn't, so a use case that's pretty common for us is I'm writing a CASB or a DLP solution. We're working with a lot of DLP vendors. And they say, we want to read the file as it comes across the wire without modifying it. And so what they could do is actually either use File API or use the Protection API, assuming their service has rights, to decrypt the file, look at the decrypted content, and then make a decision and discard the decrypted content. So you're saying if you take it out of blob storage and then remove protection?
I have one file, one protected file in a blob storage.
Uh-huh.
I have a process. I need this process with the file is streaming
Yeah.
and creates an unprotected copy of the file to the and store it to the blob storage without touching the local storage of the process.
Oh, absolutely, yeah. So however you implement this can be, it's really up to you. So in that scenario, the question was, can I, yeah, so yeah. So the question was, can I read from a storage location, let's say an Azure file blob or storage blob, read from that, extract the file, decrypt it, and then write it somewhere else without touching the original? The answer is yes. You could use either the protection API to use just a stream, and then write the output somewhere else, or you can use file API to read that protected item or stream, and then write out the unprotected one without touching the source. We never touch the source. It's up to you as the developer who's implementing this to touch the source file. So if in that scenario you said, well, I want to get rid of the source information, you'd have to instrument that on your own. We don't ever touch it.
Can I extract the protection content ID and the owner issue license?
That's a good question. So the question was, can I extract the owner or the content ID using the SDK? You can't get the content ID using the SDK that I'm aware of. Owner, I'll have to check on. I think we can get that with the protection API, but I'm not 100% certain. Okay. Yeah, and we can take that offline if you want to dive in more. I think there might be another question.
Yeah, it may be a rehash of what you just mentioned, but there's some distinction, it sounds like, between a file API and a protection API.
Yeah.
Is the protection API the one that would demonstrate, like, I've seen this stream of bytes, I want to apply a label, but I don't want to write it to disk, I just want to pass it through another stream? Is that the story there?
So the question was, is protection API where I see a stream of bytes and then I want to apply a label to that and then pass that stream along? The answer for that one is no. So the protection API exists solely to apply rights management, formerly rights management, now Azure Information Protection, to the document or that stream. So what would happen in that case is I see the stream come across, I recognize some pattern or some reason to apply protection, and then as that stream comes in, I read it, and then the ciphertext goes out the other end of the pipe, and I get a publishing license. So we're not, in that case, applying metadata. You would have to recognize some pattern using a stream to then apply the metadata to that stream. If it was a recognized format, like if it was a Word doc, for example, and we said, hey, this is a Word doc going across in this stream, we could absolutely use the file API to apply the metadata to that stream as it went through. But if it's like a generic, like let's just say it's a text file, for example, we would only be able to apply protection to that.
So I think, if you permit me a follow-up question, I think the part I'm having struggle with the API, as you've shown it here, is if I want to write that file back out to storage that is not local,
Yeah.
where it's being processed, what do I do? Do I have to write it to file to persistent storage first, and then go read it myself and stream it somewhere?
That might be a question for Ron and Trevor tomorrow. I assume that you could read it in as a stream, and then the output would be a stream as well. So you could just take, use a stream reader, or however you want to read the file in from the storage location, and then stream it back out. So it doesn't have to be files for the file API. We call it file API, but it's because we're working with file formats, but you can stream it out as well.
So default input is the stream, whether it's a file API or whether you're using the API. The file API is a little more sensitive than the underlying file format. Protection API is not. It is purely stream-based. All right. So you could, chances are, let's say if you take an XLS, read the internal stream coming in, there's nothing stopping you writing it as a doc file, except the doc file will be completely legible because the compile files don't have anything different. All right. The file API is a little more smarter. It says, okay, I recognize the
Yeah. What? Oh, yeah. So we're about out of time. I'm happy to stick around and answer any questions that we didn't answer just now, if you guys want to dive into this more. You can find our initial SDK blog post out at aka.ms/mipsdk. That's going to take you to our blog post that links to everything else that we have published right now. We're admittedly a little behind in getting a couple things out just because of all the conferences we've had lately, but next week we'll get some more blog posts out, we'll get some more samples out. And then also you can participate in our Yammer community, so it's aka.ms/AIP-Yammer. There's probably 3,000 people on there who are all like either IT pros or developers that are part of our AIP and MIP community. It's a pretty great place to ask questions, get feedback from us. All the product management team at Microsoft, as far as AIP and even Office 365, monitor that. So if you have good, any questions, not just good questions, that you want answered, go there, and one of us will either get added to it and answer it, or somebody else will come along and answer it from another organization. And finally, tomorrow, I'm doing a workshop on the sample that I just showed you. So if you don't have the C++ chops, you want to work on them, swing by at 10:15 in TCC Chalon 2. And that's WRK 2503. Thanks.